Now let's start the exercise 1.1 problems. So what is the first question? First read the question. Express each number as a product of prime factors. So we need to write this number as a product of prime factors. So in the previous class I have explained about writing the number as product of prime factors. So let's use that concept to understand this. Okay, let's solve this. So 140. So how we should write prime factors using? First check whether it is possible with 2 table or not. Check from 2 to 11. Okay. 2 sevens are 14. Okay, 2 sevens are 14. 0 as it is down. 2 threes are 6. But here what is there? 7. So 2 threes are 6. And here but it is 7. So 7 minus 6 how much? 7 minus 6 is 1. So write down small. 1 should be written in small. So 1 0. It will become 10. In 2 table 10 when it will come 5. 2 5s are 10. Next. 2 1s are 2. Again, here it is 3. So 3 minus 2 how much? 1. So 1 I am writing as small. Okay. So it will go in 2 table 15. No, it will not go in 2 table. So now observe. 3 table is it possible? No. 4? No. 5? Yes. In 5 table it is possible. So like that we need to check whether it is possible in 2 table, 3 table, 4 table, 5 table. Like that we need to check. So in 5 table 35 will go in 7 tables. So 7 on 7. Like that we should use only the prime numbers like 2, 3, 5, 7, 11, 13, 17 and so on. 19 and so on. So for this number 140, what are the prime factors? How many 2's are there? Count it first. 1, 2. So 2 power 2 into 5. 5, how many 5's are there? 1. So 5 power 1. And how many 7's are there? 7 power 1. So this how it will look like n is equal to P1 N1, P2 N2, P3 N3. Is both are looking same? Yes. So we are writing this number as a product of the prime factors. Understood? Okay, next problem. What is next problem again? Same. 156. We should be taking 156. 2 7s are 14. So what happens? 15 minus 14 is again 1. So write down 1 in small. So it will become 16. So in 2 table 16 how many times? 2 8s are 16. So 2 3s are 2 table. 2 3s are 6. But here it is 7. 7 minus 6 is 1. So I am writing 1 here. So it will become 18. In 2 table 18 how many times? 9 times. Okay. Next in 3 table. 3 1s are and 3 3s are. And 13 will go only in the 13 table. So 13 1s are 13. So how we can write 156? We can write 156 as how many 2's are there? 2. So 2 power 2 and how many 3's are there? 1. And how many 13's? Only 1. So I am writing the number 156 as a product of prime factors. Means that is in the form of capital N is equal to P1 N1, P2 N2, P3 N. Understood? Okay, next third and fourth problem. So 3825. So observe the numbers. So a number ends with 5 means it is divisible by 5. So take the 5 table. 5 7s are 35. But here it is what is there? 38. So 38 minus 35 how much? 3. 38 minus 35 is 3. So write down 3 means small. So 3 and 2 32. So in 5 table 32 it will not go. So nearest to 32 5 6 are 30. So 32 minus 30 how much? 2. So I am writing 2 here. So 25. In 5 table 5 5s are 20. Okay. Next again the number is ending with the digit 5. So it is also again divisible by 5. So 5 1s are 5. Again 7 is there. So 7 minus 5 how much? 2. So 2 I am writing here. 26. So 5 5s are 25. But here what is there? 26. So 26 minus 25 is 1. So it is 1. So 15. So in 5 table how many times 15? 3 times. So 5 1s are 5 and 5 3s are 15. Okay, next. In 153. So the number is 153. So the number is ending with the digit 3. So it is divisible with 3. So 3 5s are 15 and 3 1s are 3. Again 3 1s are but here it is 5. So 5 minus 3 how much? 2. So write down here 2. 3 7s are 20. and in 17 table 17 ones are 17. Why I am writing like this is in order to make the slow learners also to understand clearly. Okay, so this number 3825, how we are expressing it as 3825, we are expressing it as, so fast learners no need to write like this, but I am explaining for the slow learners who are unable to solve directly. Okay, 3825. So how many 5s are there? 5 power 2 into how many 3s? 3 power 2 and 17 power 1. So I am writing 3825 as a product of prime factors. So next we are going to solve this number 5005. So 5005 I am taking. So this will be divisible with 5 as the last digit ends with 5. So in 5 table 5 ones are 0 0 1. So next. So here last digit ends with 1. So it is not possible with 2, 3. So I am checking with the number 11, 7. Why? Because 21 is there. So 1. So it is possible with 7. So 7 ones are 7. So here it is 10. 10 minus 7 how much? 3. So 3. 7 fours are 28. So 30 minus 28 how much? 2. 21. So 7 threes are 21. Now it is divisible by. So we need to check for every number, we need to check from 2 to 11 tables. Okay. So 11 table. 11 ones are 11. So 14 minus 11 how much? 3. 3. 3 3 will become 33. 11 threes are 33. So the number 5005, I am writing it as 5 13 ones are 13. Okay, I am writing this as 5 power 1 into 7 power 1 into 11 power 1 into 13 power 1. So I am writing the number as a product of prime. Before going to another problem, first check whether these numbers are prime or not. So 5, 7, 11, 13 are prime factors. So the answer is right. Similarly here also. So here 5, 3, 17. These numbers are prime only. So here also this answer is correct. Understood? Okay. Last bit in the first row now. 7 for 2. So 7429. So 9 is there. So it will be divisible with 17 table. So in 17 table, 17 fours are 68. But here it is this 74. So 74 minus 68 how much? 6. So it is 6. So let's write 6 in small notation. So in 17 table, 62. Nearer to 62 number is 17 3 is 51. So 62 minus 51 how much? 10. Writing here as 10, 109. 17 sevens are 109. Okay. Next 7. The last digit in the number is 7. So it is divisible with 19. So 19 2s are 38. 2s are 30. But it is given as 43. So 43 minus 38, that is 5. So 57. 19 3s are 57. So 23 ones are 23. So for this number, what are the prime factors? 17 power 1 into 19 power 1 into 23 power 1. Okay. Understood?